All right, guys, second to the last video of the year, we're going to talk about matrices. A matrix is, unlike the movie, it is an organization of numbers, and there are tons and tons and tons of applications of matrices. I've listed a few down here, but they also are used extensively in computer animation, in anything that uses a spreadsheet is really a matrix, in organizing data, decoding any kind of things, all kinds of good stuff. But this is a matrix, and what it might be used for would be to say, I own two McDonald's. I own the one on, whoops, my pen isn't working. Let's say I own the one on 173 and I own the one on North 2nd. And I want to keep track of how many shakes, Big Macs, and chicken sandwiches were sold today or something. Okay? And it's just a way of organizing data. And we're going to do a little bit of operations today, but you could add this if you kept this data. This was Monday's chart, and then you kept one that was Tuesday and one that was Wednesday. Then you could add the entries and figure out what you used in inventory for the week, etc., etc. What you need to know for the lesson today is how to state the dimensions of a matrix. I'll come back in a second, but dimensions of a matrix are the number of rows and then columns, okay? So does this have a picture? Here we go. This is a 2x3 matrix, same as the one we were just talking about. Rows go this way, okay? So you actually count how many there are by counting up and down, but you got to remember the row is what's going across. And then the columns go this way. So this one has 3 columns. This is a silly little thing. It says, what to remember, just remember, think of RC Cola. I don't know if some of you even know what RC Cola is, but it's a poor man's Coke. Okay. I grew up with RC Cola. All right. So this is a 2-row by 3 columns. So it's called a 2x3 matrix. This is all 1 row with 4 columns. So this is a 1x4 matrix. All right. So this is and this is the size we're going to use a lot. And it is 3 rows by 1, 2, 3, 4 columns. So it's a 3x4. All right. Now, you can add or subtract matrices if they are exactly the same size. Otherwise, you write undefined. So these are the same size. This is a 1x2, and this is a 1x2. So you can add them. You simply add row 1, column 1 to row 1, column 1. So you get 6 plus 3 is 9. Whoops, you don't need a comma. And then you add row 1, column 2 to row 1, column 2 over here. -2 plus 1 is -1. And you're done. Okay? This is a 2x1. And this is a 3x2. So you cannot add or subtract. You actually would be able to multiply these. Multiplying matrices is very tricky. Your calculator does it, etc. But we're not going to do it this year because of time constraints. I can definitely put a link in Classroom to multiplying matrices, my video from last year, if anybody's interested in how that works. Or again, it is possible to do it on your calculator. But the trick is with multiplying is these outside dimensions have to be the same. And your resulting vector or your resulting matrix will be the size of, this would be a 1x3. Okay, be the size of the internal two dimensions. Really weird, complicated process. All right, but for today, we're just doing addition and subtraction, and then we're going to do some review of word problems. All right, this is called a scalar. If we were doing our pre and post test, our final exam for this course, there's a scalar problem where it says, here's a list of the prices that you paid for something, your cost. Okay, and then it says, what if I want to mark them all up 5%? So you would multiply by 1.05 as your scalar and see what the new prices would be. All you do is you multiply everything in here by 3. So we'd have -6, 9, -3, and 3. We are not having a final, so you don't have to do this, but it's just a use of when you would multiply by a scalar. This one, these are the same size, so you would first multiply everything here by -3. And then you would subtract these back here. Be careful. 6 minus -6 would be 12. -12 minus 5 would be -17. And 15 minus 4 would be 11. Now, you can do those on the calculator, but honestly, they'll take way more time to type in to make it worth doing on the calculator. All right, an augmented matrix for a system. We're going to learn the magic of what this means tomorrow. But what it means is you're going to take a system, make sure it's lined up so you have x, y equals, and then whatever it equals over here, okay? And then you're going to take out the x's and y's. So you're going to have a 1x, 5y, and a 17. And down on this one, you have a -1x, a -4y, and a -12. This is called the augmented matrix. It simply means you've taken out the variables and only left in the coefficients. But remember, again, before you do that, these have to be the x's, these have to be the y's, and these have to be the constant term on the other side. And they will put in a dotted line to show where the equal sign was. Okay? When you go to type them in on Delta Math, I can't remember if they put that dotted line. They may not. A lot of times they just leave it off. So for this one over here, they already line up. So you have 2x, 1y, -18, -3x, 6y, -3, and that is the augmented matrix. And it is a 2 by 3. You will need to know that when you go to put it in your calculator tomorrow. All right, augmented matrices, okay, this is from your book. I just want to show you. There you go. That's what it looks like. It is the coefficient matrix would just be this matrix out in front here. And you use the coefficient matrix if you solve by different types. But we're simply going to do row reduction this year, and we're just going to let our calculator do it. I will show you how it's done by hand tomorrow in a video real quick. Okay. But there's some notes on augmented. So these two I just put on here so that we could talk about rearranging these. You would need to add the 4x over here. So then you had them lined up, -7x plus 4y equals 18, and 4x plus y equals -7. And then the augmented matrix would simply be -7, 4, 18, and 4, 1, -7. And again, that is a 2 by 3 if you were to enter it in your calculator. All right, this doesn't work. You do have to make it go x, y equals constant. So this would be -7x plus y equals 0. And this one would be 6x plus y equals 13. I realize they're lined up here, but you need it so that it's in order that you're going to know the answer. When the answer comes up, it's going to be in the same order, so it's easier to do it x, y, and you need the constant to be on the left. All right. So last kind, these are the ones that are magical to do because we can solve those last systems that we just did by hand pretty easily. But a 3x3 is very complicated to solve by hand. You did a few if you took Honors Algebra 2 last year, maybe even regular Algebra 2. I'm not even sure where it fell in the curriculum, so I don't know if you did it last spring. But if we do a 3, again, it has to be X, Y, Z. So this one is okay. This one in here would need a 0Y. And this one is X, Y, Z, so that one's okay. So you'd have negative 5, 1, 6, and 27 for the first equation. For the second equation, you'd have to have 3, 0, negative 1, and negative 17. And it's real easy to forget those, so make sure you have everything in X, Y, Z, or A, B, C, or whatever order you're doing it in. They have to all be the same, and then you have to have equals constant back here. All right, so this would be a 3x4, and that's what we're going to do most of on our calculator tomorrow. Let's see, this one would be negative 4x plus 0y minus 5z equals negative 11. This one is in order, and this one is in order. Okay. Some of them on Delta Math are pretty tricky. You have to rearrange and combine like terms, whatever, to get them. And then you write negative 4, 0, negative 5, negative 11. Negative 4, negative 4, negative 6, negative 30, 1, negative 2, negative 4, negative 21. All right, more on these tomorrow and actually using them to solve systems. For today, I want to review word problems of systems. These were always my favorite kind of word problems because I think if you spend a little time doing them, they're for the most part pretty straightforward, and students kind of figure these out, one of the kinds they feel most confident in. My suggestion is you read through carefully, then go back and reread the question. So it says, Mark and Wilbur each improved their yards by planting daylilies and ornamental grass. They bought their supplies from the same store. Mark spent $172 on 3 daylilies and 4 bunches of grass. Wilbur spent $161 on 14 daylilies and 7 bunches of ornamental grass. What is the cost of 1 daylily and the cost of 1 bunch of ornamental grass? Please do not do this. You need to specify what it is. Is it the number of daylilies, the cost, the weight, the height? What is going on? It says, what is the cost? So you could say cost of daylily, or you could maybe abbreviate dollars for daylily, dollars for grass. Okay. In Delta Math, there are some where you have to pick the right, what are they looking for like this? And then there are some where they tell you what X and Y will stand for. Some of each. For this particular kind, you just take each person's order and you change it into an equation. $172 was spent on 3 daylilies, which is X, plus 14 bunches of grass, which is Y. Now we could rearrange the order on that, but it doesn't matter for this problem. And then Wilbur was 161 total, but he bought 14 daylilies. Okay, that was X, and 7 bunches of grass, which is Y. All right, now I am going to ask you to solve some of these today. I honestly could just skip this because I think you're good at this, but I'll go ahead and multiply this one by -2. So up here, this one would stay, maybe I'll rearrange the order. 3x plus 14y equals 172. As I multiply by -2, this would become -322. Did I do that right? I think so. And this would become -28x and -14y. Okay, sorry if that was confusing. I just rearranged them in XYZ order as I went. Then if I add, I get negative 25x equals negative 150. So x equals 6. I hope I'm doing this right. I am checking my answers here. Yep. All right, and then if I plug that back in somewhere, it doesn't matter. If I plug it back in this bottom one, I'd have 161 equals 14 times 6 plus 7y. This is 4, carry the 2, 84. So I need to subtract 84 from both sides. Trying to skip some steps here. So this is 77. And 7y, if we divide, we get 11. So the answer, these really need to be answered as a sentence. You would say cost of one daylily is $6 and one ornamental grass is $11. All right. Maybe I won't spend time solving all these because I know that you guys know how to solve a system now. All right. Yellowstone National Park is a popular field trip destination. This year, the senior class at High School A and the senior class at High School B both planned trips. The senior class at High School A rented and filled 13 vans and 14 buses with 864 students. High School B rented and filled 6 vans and 7 buses with 423 students. Each van and each bus carried the same number of students. How many students can a van carry? How many students can a bus carry? Okay, so this is crazy business. All of this, there seems like a million unknowns, but if you just read the questions at the end, it becomes so much easier. So we have x equals number of students in a van, and y equals number of students in a bus. Now, if you're like me, you read this and it said each van and each bus carried the same number of students. They're not saying the vans and the buses are the same size. They're saying every van had the same number and every bus had a different same number, but they were the same in each bus. So that was confusing to me. All right, go back up here though. We have 2 sentences. We have school A. They had 13 vans and 14 buses. 13 x's plus 14 y's equals 864. And then bus school B had a separate sentence, and theirs said 6 vans and 7 buses equals 423 students. Okay, I'm going to assume you guys can solve this and find the number in a van and number in a bus. I'll come back and do it so that you can check your answer in the notes, but I won't do it on the video. All right, we have the school that Sarah Wong goes to is selling tickets to a fall musical. On the first day of ticket sales, the school sold 12 senior citizen tickets and 8 student tickets for a total of $132. The school took in $51 on the second day by selling 1 senior citizen and 4 student tickets. So figure out the price of each senior citizen and the price of a student ticket. So we have x equals dollars for senior citizen ticket, and y equals the price or dollars for a student ticket. So on the first day, we had 12 senior citizens and 8 students for a total of $132. And on the second day was $51, which would go over here. And it was 1 senior citizen and 4 students. All right, this is a pretty easy one I could solve by hand real quick. If you multiplied this by -2, you'd have -2x minus 8y equals -102. Then I could add these two. I'm not going to bother to rewrite them. I would get 10x plus 0y's right here if I'm adding the blue and the green. And equals over here 132 minus 101 would be 30. Divide and get x is 3. If I put that back in the red equation, if I subtract 3, oh, there we go. I'm okay. I can subtract. Oh, it's not 5y, it's 4y. That's why I was so confused. I'm like, it's not divisible. What did I do wrong? Okay, I put the 3 in here. So 1 times 3 is 3, plus 4y equals 51. If I subtract 3, I get 4y equals 48, y equals 12. So it's $3 for senior citizens and $12 for students. Yikes. Hope it's something students really want to see to pay $12 for it. Okay. Last kind. Delta Math has some coin problems. Not my favorite. I think these are kind of silly. Samantha has $3.35 worth of dimes and quarters. She has a total of 20 dimes and quarters altogether. Determine the number of dimes and the number of quarters that Samantha has. If you know what she's got, then you should be able to just count it, in my opinion. But these are pretty easy to understand, so I did assign a couple of these. She has determined number of dimes and the number of quarters. So you would say x equals number of dimes, y equals number of quarters. Now, you have to know the value of these. I will tell you that these are frequently not on the SAT because it's a cultural thing. If you're a foreigner and you came here to take the SAT to get into college, you might not know the exact worth of a dime or quarter. Same with deck of cards is often not on there. But we're going to say, let's see, $3.35 worth of dimes and quarters. So we're going to make an equation that says a dime is worth 10 cents, okay? 10 cents each for the dimes, 25 cents each for the quarters, and the total value of the money is $3.35. So that's a value sentence. The value of the dimes plus the value of the quarters equals the total value of money we have. And then we need to write something about the total coins, but this one is tricky. It says a total of 20 dimes and quarters altogether. Okay, it's not tricky, just kidding. X plus Y, the total number of coins is 20. Sometimes it's trickier, like she has 12 more dimes than quarters or something like that. This one wasn't tricky, I was lying. All right, so I could do substitution here, or I could do elimination. I'm kind of a fan of elimination, but if you wanted to do substitution, you could say x equals 20 minus y, and then put that in here. So we'd have 0.10 times 20 minus y plus 0.25y equals 335. Oops. These are coins, so they have to come out nice. Let's see if I combine these. Subtract 2. And I need my calculator. 135 divided by 0.15. Is 9. So we plug that back in here, and we get 20 minus 9, x is 11. Now go back up here and make sure you have them right. X is 11 dimes and 9 quarters. This would be $1.10. So definitely a total of 20. 9 quarters, 9 times 25 is 225. If you add it together, you get 335, so we're good. So then you would put that in Delta Math. Okay? Good luck.